Today I'm going to be teaching about related rates. Now let's start off with the definition. Related rates are problems involving finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. The rate is usually with respect to time. Now you may be asking yourself, where would we see related rates in the real world? Well, maybe you can see related rates on a car. The rate at which you push the gas pedal affects the rate at which the wheels spin, or the rate at which your gas is being guzzled, maybe in sports. The rate at which an athlete uses muscles is related to the rate at which he or she sweats. Or maybe on an old iPod or MP3 player, the rate at which you spin the wheel affects the rate at which the volume increases or as fast a song rewinds or fast forwards. Now, before we start with the examples, I have a few general steps to help you along. 1. Draw a picture. 2. Identify what is being looked for. 3. Identify given information. 4. Identify the equation that relates to the variables. 5. Take the derivative of the equation that relates to the variable with respect to t, which is time. 6. Substitute the given rates and values into the derivative equation. 7. Use the equation in step 4 to find other needed variables. And 8. Solve for the unknown/desired quantities. Okay, example 1. A pebble was thrown into a pond, creating a ripple with a radius of 3 centimeters, growing at a rate of 1 centimeter per second. Now the question is, at what rate is the area of the circle growing? First, we are going to write out what we know. First, we know that the radius equals 3 centimeters, and that the rate that the circle is growing is a rate of 1 centimeter per second. Now we have to think to ourselves, what equation will we use for this problem? Since we are trying to find the rate of the area of the circle, we will obviously use the equation for an area of the circle, which is A equals pi r squared. Since we're trying to find the rate of the area that the circle is growing, which is the derivative of the area in respect to time, we have to find the derivative of the equation of the area of the circle with respect to time. So this will be derivative of the area in respect to time, which is dA over dt, equaling pi d over dt equal times r in respect to t squared. Now to solve for this part of the equation, all we have to do is a chain rule. So the rate that the area of the circle is growing would be equal to pi 2r t times dr over dt. And so now all we simply do is plug in what we know. We know what r equals, and we know what dr over dt equals, which is the rate that the circle is growing. So all we do now is just simply plug in. Three centimeters. R equals 3 centimeters times the rate, which is 1 centimeter over seconds. So now we just simply solve. And we will get 6 pi centimeters squared over seconds. So the answer we have is the area of the circle is growing is 6 pi centimeters squared per second. Problem number 2. Now, for problem number 2, a 20-foot ladder is falling straight down a wall. The bottom of the ladder is 8 feet away from the bottom of the wall, and the bottom of the ladder is sliding down at a rate of 4 feet per second. How fast is the ladder moving straight down? First, we are going to mark the diagram. We are going to make 8 feet x, so x equals 8 feet. And if x is 8 feet, then the rate of x, which is dx over dt, will equal 4 feet per second. Now we are going to make the height of the wall y. Since we are trying to find how fast the ladder is moving straight down the wall, and we already know the height of the wall is y, the only way to know how fast the ladder is moving straight down the wall is to find the rate. So we will be finding dy over dt. So we're going to assume that the ladder and the wall make a right triangle. So for this, we will be using the Pythagorean theorem. And in this case, it's x squared plus y squared equals 20 squared, since the hypotenuse is 20. So we're going to simplify this. So it's x squared plus y squared equals 400. Now we have to find the derivative with respect to time. So with this, we multiply by d over t. So the derivative in respect to time. So for the left, we are simply just going to do the chain rule. And this will turn out to be 2x times dx over dt, which is the derivative of x in respect to time, plus 2y times dy over dt, which is the derivative of y in respect to time. Now the derivative of constant, which we have here, 400, is going to be 0. So we simply just mark that. So in order to solve, we know what x is, we know what dx dt is, and we are trying to find what dy over dt is. So we still need to find y. And to find y, we can simply just use the Pythagorean theorem that we have up here. So to find y, we do x squared plus y squared equals 20 squared. So we have to solve for y. So x is 8, so we have 8 squared plus y squared equals 400. 64 plus y squared equals 400. And after we solve, we will get that y equals 18.33. So now we have all the components and variables that we need to solve for dy over dt. So we just simply now plug in. So 2 times x is 8, so we plug in x. And the rate of dx over dt is 4, so we just multiply by 4 plus 2y we now know is 18.33 times what we are trying to solve for is dy over dt. So now we solve. So this would be 64 plus 36.66 dy over dt equals 0. Remember, we are trying to solve for dy over dt, so we subtract 64 from both sides. So we're left with so we divide by 36.66 on both sides. So we have dy over dt equals negative 1.746 feet per second. Now we have a negative answer, and this negative answer makes sense because we're trying to find how fast the ladder is moving straight down. And the negative just simply means that it is moving straight down. So the rate at which the ladder is moving straight down is negative 1.746 feet per second. So for the third problem, a car and a truck are driving towards each other towards an intersection. The car is traveling at a rate of 60 miles per hour and the truck is driving at a rate of 30 miles per hour. The car is 0.8 miles away from the intersection and the truck is 0.6 miles away from the intersection. What is the rate in which the distance between the car and the truck is changing? So to start off, let's mark up this picture. So we're gonna say that the distance that the car and the truck is s. Now we're gonna say the 0.8 miles will be our y, and the 0.6 miles will be our x. So let's write that down. Y will equal 0.8 miles, and x will equal 0.6 miles. And we are trying to find s, the rate of s. So what will be 60 miles per hour? 60 miles per hour will be the rate of y, which is dy over dt. And we are going to make it negative 60 miles per hour. Because since the car is traveling at a rate of 60 miles per hour, that means that the distance is decreasing negative 60 miles per hour. So that's why, since it's decreasing, there's a negative. And same goes for the 30 miles per hour the truck is traveling. Since the truck is traveling at a rate of 30 miles per hour, that means the distance is decreasing at a rate of 30 miles per hour, which is why dx over dt will be negative 30 miles per hour. So the roads are perpendicular to each other, so we assume that this will be a right angle. So the equation we are going to use is the Pythagorean theorem, which is x squared plus y squared equals s squared. Now we have to find the derivative in respect to time. So d over dt So for both sides of the equation, we will simply do the chain rule, which is 2x times dx over dt plus 2y times dy over dt equals 2s times ds over dt. Now we can't solve just yet because we are trying to solve for the rate of s, which is ds over dt, but we still don't know the s. So we are going to use the Pythagorean theorem to help solve for s. As we mentioned before, the Pythagorean theorem in this case is x squared plus y squared equals s squared. We know that x is 0.6 miles, so 0.6 squared, and y is 0.8 miles plus 0.8 squared equals s squared. This is 0.36 plus 0.64 equals s squared. 1 equals s squared, and s will equal 1. So now we know all the components for the derived equation, so now we just simply plug in and solve. So 2 times 0.6, because x is 0.6, times negative 30, plus 2 times 0.8, because y is 0.8, times negative 60, will equal 2 times 1, because s is now 1, and we are solving for the rate change of s in respect to time. So when we solve, it will be 1.2 times negative 30 plus 1.6 times negative 60 equals 2 ds over dt. So we just further simplify. So it's negative 36 minus negative 6 equals 2 ds over dt. Be negative 132 equals 2 ds over dt. You divide by 2 on both sides because we are trying to find the rate in which the distance between the car and the truck is changing. And as we said before, that is ds over dt. So ds over dt equals negative 66 miles per hour. And again, we got a negative number because the distance between the car and the truck is obviously changing. So the rate in which the distance between the car and truck is changing equals to negative 66 miles per hour.